in an ellipse, x squared by a squared plus y squared by b squared equal to 1. This was an ellipse. Huh? Do you recall the director circle of an ellipse? Locus of points P, from where if you draw tangents, then those tangents would be perpendicular to each other. That was the director circle. P is said to lie on a director circle if the pair of tangents drawn from P are perpendicular, right? And do you realize the director circle of an ellipse is x square plus y squared is a square plus b square? That was the director circle of an ellipse. Yes, please. Can you just wait for a little while? You can be seated. Please have a seat. Director circle of an ellipse is x square plus y squared is a square plus b squared. What happens? In this case, if you take any point on the circle, the director circle has a center common with the center of the ellipse and its radius is root a square plus b square. From any point on the circle, if you draw tangents, pair of tangents to the ellipse, they will be perpendicular to each other. If I have a hyperbola, if this is a hyperbola, then the director circle of the hyperbola, that means the pair of tangents should be perpendicular, the director circle of the hyperbola is going to be, the director circle of the hyperbola is going to be x square plus y squared. Just replace b square by minus b square to get the equivalent proposition in a hyperbola. So x square plus y squared will turn out to be a squared minus b squared for a hyperbola. Yes or no? If I had a conjugate hyperbola, which is like y squared by b squared minus x squared by a squared equal to 1, which is a CH, this is a H, hyperbola, conjugate hyperbola, right? Now in this conjugate hyperbola, the director circle would be, you'll have to interchange b and a. Director circle is going to be x square plus y squared is b square minus a squared. Now there is an issue. Look, between b and a, if one of them is larger, right? If a is larger than b, then this director circle is real, but this director circle is imaginary. Yes or no? Root a square minus b square is the radius of the circle, and root b square minus a squared is the radius of this circle. Now only one of them is real if b and a are different. You know? That means if b and a are different, if b not equal to a, then between this director circle and this director circle, only one will be real. Only one will be real. If b is not equal to a, only one director circle would be real. If a greater than b, then this hyperbola will have a real director circle and this will have an imaginary director circle. If b is more than a, this director circle would have, this director circle would be real and that would be imaginary. Yes or no? That means a director circle will exist either for the hyperbola or its conjugate if b and a are different. But if b is equal to a, then the director circle will be x, for both will be x square plus y squared equal to 0. But if x square plus y square equal to 0, then x equal to y equal to 0. That means the director circle is a point circle. Then the director circle will be a point circle, which is the center of the hyperbola, which would be the center of the hyperbola. Yes or no? And when is b equal to a? In a rectangular hyperbola. In a, remember that b is a in a rectangular hyperbola. B will be equal to a. So in a rectangular hyperbola, the director circle is a point circle. And what is that point? The center of the hyperbola. What is that point? The center of the hyperbola. In a rectangular hyperbola, The director circle is a point circle, and that point is the center of the hyperbola. If A greater than B, the director circle to this hyperbola would be real and this would be imaginary. If B is greater than A, this director circle will be real and this would be imaginary. So if B is different from A, between the hyperbola and its conjugate, only one will have a real director circle. Yes or no? Are you all okay with this or not okay with this?